Hey, hey, how's it going? Hope everything's going good with all of you. I am just now getting started this morning. Got my coffee, 7-Eleven, got my onigiri, or I already ate that, but just committing some changes here from last time. I'll go ahead and just push those for all of y'all who are watching. Let's see. Okay. But anyway, yeah, for all of you who want to follow along here, I'm going to, what should we do here? Oh, there's my thing. Okay, let's just go ahead and paste our source code into the channel. Hopefully, y'all can hear me speaking very without issue. Let's do a little bit of review on what we did last time, and then we'll get started. I think I'm about to stream for an hour and a half here, to about 10 our time. But yeah, I hope you're all doing good. I'm feeling great this morning. I've been so incredibly tired lately, but I don't know. I don't know if I'm getting old or what, or the season's changing. But I've been trying to get to bed earlier. And, it seems like 8 hours is not enough. Okay, let's see. Cool. So, just let's look at through GitHub here real quick. Just a quick review what we did. One thing we did was we did move the game loop to its own file here, just to get it out of the main, just to clean things up a little bit. And we just run the game like this by calling game loop. Yeah, just basically did that for that change. And then we did some. Our plan was like, we did some of this. We implemented independent game loop. Okay. What we need to do is we still need to kind of run hitbox data through the collision system, create event structure, which we started on, and we need to generate hitbox events, right? Okay. And we need to create tests and test the actual event generation. But really, like, before we can get any of that done, we have all this as well. We have to actually create a character and hitbox data for them. Before we can get any of that done, really, we need to kind of like split our. Well, I'll say what my intention is to split up the collision system into stages. Now we could have everything running in just the collision function, or sorry, the collision system function here, right, in one go. But I think I talked a little bit before about translating the hitboxes so they're in the same space, so we can actually do collision, and like whether or not we want to do that in the very end of our, like, the deep part of our loop, or do we want to do that as a pre-stage. And I also talked about how we don't necessarily want the collision system to have knowledge, or it doesn't really need knowledge of how our persistent game data is actually structured. Hey, good night, Deader Than Disco. Sorry, maybe starting late for you. But yeah, basically, I want to split the stages into. Sorry, I want to split the collision system into stages where each stage only thinks about or only cares about the data structured in one way, right? And the most efficient way to process these things on a modern CPU is to do it in a tight loop, uh, iterating over a flat array, effectively, right? It's going to be the most cache friendly. As long as the number of items we are processing at a time can fit nicely into a cache line, that means we don't actually have to pull it from main memory for most of the time. Now, if we're trying to read from like a very deep hierarchical like data structure for, like, say the character data, like, action, there's a set of actions, you have to look into an action. Inside the action, you have to look in the timeline will look at a particular frame, and in a particular frame we'll have a list of hitboxes, etc., etc. That's going to require us to pull in chunks of that structure we don't even need, or we don't even care about, right? And I like to think about the stuff way ahead of time. So our kind of goal is to get at least one of the stages we need to work on will be translating, uh, you know, that deep hierarchical structure into something very, very flat, into the data we only care about. So let's go a little bit to our design doc, our design doc. It's getting a little disorganized as we're adding more stuff here. So character data, hitboxes, got that. Input handling, da, da, da. So let's go down to collision system real quick. This is right, collision system. Okay, so we're gonna have stages. So the first stage will be to translate character data, or translate data in our character data structures to flat or easy to process flat hitboxes. Okay. Now, yeah, Fatty's got to go. So basically, the first stage is we're going to translate all the data into cache-friendly flat arrays and hitboxes. Yeah, so that we can just loop over them really quickly. And then the second stage, is going to be to actually generate overlap events. So we're going to process hitbox collisions and generate overlap events. Am I missing something here? So the part that actually needs to like detect if hitboxes are overlapping basically doesn't need to care about the structure of the character. And then this part of the stage, this part of the collision system doesn't need to care about actually doing hitbox collisions. So we can separate those. And in order to like test each part individually, we need to basically split those into separate functions. Now, I'll probably keep so I'll have to split those into separate functions so that we can actually write unit tests for each. I don't know if I really need to write unit tests for the translation part. I mean, we could do it actually. It's kind of boring though. But effectively, we're just doing big for while loops to iterate over all the characters that are active, their current active action, and what frame they're on, checking to see which hitboxes actually are active during those frames, and then copying them over. The kind of more, I guess, but still, I guess the interesting part is using temporary memory to actually store those hitboxes. Yeah, funny enough, yeah, there are tests in game development. It's becoming more and more critical, right, as complexity of these things go up. But there's a lot of pressure not to write tests because producers, publishers, they want to see results as soon as possible, and it's just sometimes easier just to put things on screen and show it to them. It's kind of like this project, right? It's not as exciting writing tests. Like I get to start trying to spit things out on the screen, but when we start getting into the nitty gritty of implementing a lot of stuff, if we don't like actually make sure our core data structures and the way we actually pipeline our data around the system is built well on a solid foundation, we're going to start seeing bugs pop up, and we're going to start spending a lot of additional time hunting down those bugs, trying to actually see how the game state is changing, when these things are processing in an active loop, right? Data is constantly changing, so it's going to be hard to track issues, especially ones that would like be persistent across frames. So at the very least, we want to be sure that our parts, our systems, our data structures are solid. They work as expected. Um, okay. And actually, the kind of cool part about tests as well, people who are looking to learn about how your code works can look at the test, and the test kind of says, no, this is like the proper way to use the code, right? So, do QA people in the game studios? Oh, so you're talking about like, oh yeah, you're asking if QA people in game studios write unit tests. No, generally that's not the case. I know in software development you have QA engineers who do that kind of thing. Um, there's not so much QA engineers in the game industry. Um, and honestly, I don't necessarily know the value. I mean, obviously there's gonna be. I say obviously, I can see how there could be value in other people writing your test for you, but for me, tests again, they're not only to validate your code to see if it works, but it's also to provide kind of documentation on what's happening, right, in your code. It's kind of hard to document a lot of stuff just using plain language, right? But if you write it down in test, it shows like this is how the code is supposed to function, you know. And if of course, if someone goes in and makes changes to that code and it doesn't function anymore, they can look at the test and see what was intent. Uh, if you're still in college, cool, man. Good luck to you. You might get lucky. Um, I don't know what kind of side projects and stuff you do, but you might, once you graduate, send them a resume, cover letter saying what you're passionate about, what you want to work on. Tell them your experiences, what you think you want to do. Maybe they'll, I don't know, just find you fascinating and give you a shot at least to interview. Like, uh, I mean, I did have experience, so it's not the same boat. But after I worked on Killer Instinct, I wasn't interested in going working at ArcSys. It was kind of like a dream of mine for the longest time, and I just kind of wrote them a very passionate cover letter and send them my resume, not even expecting a response, to be honest. But yeah, the end up hiring me. I was trying to look for a designer role, but they ended up hiring me as a gameplay programmer, which is pretty much close to what I was doing on Killer Instinct anyway. So sometimes you get lucky, but again, different situation. I had years of experience working on games at that point. It's fighting games, so I can't. It's not apples to apples comparison. Oh yeah, I went to school for CS, math, and Japanese. I ended up only taking the degree in Japanese because effectively it was like I'm in school way too long. I need to get out of it here. I'm already working as a software engineer. I don't really need to have the CS degree to continue my career, and I don't want any more student loan debt. So I took the Japanese degree and got the heck out of there. Yeah, Deader Than Disco. Like I agree. I think you should have foundation of tests and I before I started working in game development, I was working as a like a front end back end engineer for a kind of typical web service type thing, making some cell phone applications to run against that back end. And obviously, yeah, we had tests running on everything back then. And I went from there to working game studios and realized nobody writes tests. Uh, it's you know game production is more like movie production, where it's like things are constantly in flux. There isn't and often, it's not like you're writing code that's necessarily going to be used 5, 10 years down the line for a lot of these smaller games. It might get completely thrown out. So even if it's not spoken, there's a little bit of an assumption that this code is this kind of utilitarian, right? It's just to get the designer's intentions down and working. It's not something that should be valued and kept into the future. So it's a little bit of a different mindset. But me, on the other hand, I've been writing my own engines and things like that for years, and I still have code that I wrote 10 years ago in my in Fearless Nights. So a lot of that stuff I built using, started out using, I built it with tests in mind, by writing tests, making sure that worked. Because when you're building these like long pipelines and you don't test anything till you get to the very end of it, because you can't really, right? If you're talking about the actual game, you have to have almost all these pieces in place before you can really start seeing anything on screen. So anyway, just to digress here. So yeah, these are our stages, and I want to test this, and I want to test the processing hitbox collision. So I think today, at the very least, we can test our we can actually test hitbox collision, right? Yeah. Yeah, Exacool, you're pretty on point there about QA. Well, big studios just relying on QA all the time. It's a big part of it. It's like the idea. It's like you're in a sprint to get everything done, but obviously you break things along the way, and then you just kind of hope that QA can find everything, or at least find everything that's critical, and then you can try to fix things in the end. The problem is when you have like large structural issues with your code, or you can't make changes because you have so much content already developed and invested into the game that you just kind of have to like patchwork things together. I'm not gonna say which game, but I did work on a port of a game to modern consoles, where effectively a lot of the cinematics that were translated over from an older version of the engine ended up breaking because of just like, oh, we went from like, I guess they went from like 30 FPS to 60 FPS. None of the cinematics were intended to work that way, and you would get these like frame boundaries where the camera would jump because there was no longer keyframe data, and then it would jump back to the main scene, and then you'd run a teleport bugs because gameplay was tied to where the cinematics ended up at, and that was a nightmare of just going through and fixing by hand a lot of those cinematics. So even as a programmer, I wasn't really writing a lot of code on that project. I was just using my experience to debug that stuff and fix those issues in the content. That kind of stuff is very common. But yeah, a project like that is too late. You can't go back and rewrite all that stuff. It's, code that was written a decade ago or something like that, and you only have time to like fix the issues. Yeah. But yeah, process hitbox collisions generate overlaps. So let's look at what we got here. So I wrote this while loop here, right? And the idea was like, we're gonna go through all the entities. Why did not we go through all the entities, make sure it doesn't check against itself, and then we'll do the overlap events, right? And we built the basic structure of this right here. I think somebody mentioned to me in the Discord that I could actually just do a for loop over all the items in the list. The problem is we would have to generate a list, and I haven't done that yet. So let's just do a little bit of brainstorming here, right? I made these test hitboxes here, these attack boxes and vulnerable boxes, just so that we could like compile here. So let's think a little bit about what do we want to do here, so that we can pick the right format for our data. So the concept is we're going to loop over like some list of attack boxes, right? And we're going to pass in the attack box. Let's just say attack box. That's going to be, this means a capture in Zig, I'm pretty sure. We also need an iterator, so index. I think that will give us the index, because I want to record this for our collision event. And then we're gonna need to like iterate for some list of vulnerable boxes, something like that, right? Conceptually, and then we'll do what's inside here, right? I'm just trying to clean up this code a little bit. We're just going to copy paste this because we're going to be using this. We don't need to do this, do we? No. No. So it needs to be vulnerable box, attack box index. And actually, we don't necessarily need these. So we're doing attack boxes per entity. So how do I want to handle this? Oh yeah. So this is gonna be on a per entity basis, right? So it's gonna be more like something like this, right? For attacking entity boxes or something like that, right? That's the idea. We'll have something like attack boxes captured, right? And then we want to also capture the attacker index or something like that, so that we know which entity was actually triggering this stuff, right? And then for each of the attack boxes, we want to check to see if each attack box hit any vulnerable box in another entity. So we're going to get a lot of for loops here by doing this, right? So we would have to add another layer here, right? So we can go through defending entity boxes, something like that. Oops, and did I do things right here? Yeah, defending. So we have to do something like this. So defending entity boxes, and then we'd have to do something like this. Hold on. Where we make sure that we don't want to make, don't want to check the attacker against itself. So it'd be defender index, right? Oops. Make sure the attacker index is not equal to the defender index, and go on to the next loop. And then we have to like actually loop over all the vulnerable boxes, right? And we're going to pass in the vulnerable box. We don't care about the index so much for now. We might need it later, just to see like the point at which two boxes collided. In the future, we might want to actually spawn a hit spark from there, but that's for later. We don't really care about the overlap box itself yet. Okay. So this is the basic concept. Go through all the attackers, or at least all their attacking boxes. We go through all the attack boxes within each entity, and same with defending entity. These names I might change, but so we check the vulnerable boxes, and then we check for overlap, and we generate hit event. Okay, so the data structure we want is not actually this. It's going to be like an array within an array, effectively. And are we going to use an array list, or are we going to use flat arrays? What I mean by flat array, what I mean is pre-allocated arrays with compiled time known sizes. Well, if we used compiled time known sizes, that means we couldn't just do a for loop like this, because we're only going to use up to a certain number of boxes per call to this collision system, right? Because even if we allocate, say, 10 slots for a box, we may only need one for this particular action. So we'd have to go back to using a while loop or something like that. Now, if we use something like an array list, which we reviewed before, right? Let me see where it is in our documentation. Zig notes, it was like an array list, right? If we use an array list, we can iterate over it, I'm pretty sure, just by getting, what is it? By getting items. In that way, we can keep the memory allocated without reallocating each frame, but keep the size small. Pretty sure we can do that because we can set the capacity, right? So let's start with that for now, right? So let's do this. Let's copy some of this code real quick. Let's copy this one. Sorry, when I'm talking about all this tech design stuff, you end up getting into going down rabbit holes inside of rabbit holes, and you kind of lose track of where you were thinking. So we don't need array lists of array lists. We just need, well, let's just say we need array list of array lists. Yes, exactly, Krakatoa. Like I was saying before, if we used compile time known array sizes, we would have to keep track of the number of elements that are used in each array, each frame, and that could add to bugs. And also means we can't just write a simple for loop. But if we use this array list, which does keep track of the number of elements inside of it, even if it has more allocated slots, we can just use a for loop, I think. Keep that in mind. Now, we could, on the other hand, not use the array list directly. We could use something like, we could keep the compile time known, arrays with compile time known sizes, but use slices inside of them. And slices let us create runtime known sizes, right? So say we create an array that had 10 slots again, but the slice, you could have sliced and it's only of size 5. That could work as well. So just thinking of the trade-offs here, there's a little bit more complexity in using an array list, but also we're not actually writing the code that's tracking the slices ourselves. I don't know. We'll stick with the array list for now. If we run into a problem, we can switch to using slices. Okay. And also this way we can have this handle our allocation, right? So how do we want to write this actually? So I'm just trying to think about the structure here. It's gonna be a list of boxes. So it's gonna be something like this, right? It's gonna be so the array list you pass in the type, right? So it's like standard array list. The type would be a standard. Does this work? Would it be a standard array list of hitbox groups? Wait, hold on a second. Give me Oh, this is not so bad actually. We don't actually need an array list of hitbox groups because I think I mentioned last time we're only going to support looking at one hitbox group per action per frame. In the future, we could support multiple hitbox groups, but each group has multiple hitboxes inside of it. So we don't, at this level of abstraction, we don't care. right? So this is the type, and I guess we should look at the code for this. We can't look at the code. Okay, let's look at Zig standard array list, right? So this is a comp time function. I like the documentation here. It's so easy to understand. It's just a struct that internally stores an allocator used for memory management, and to manually specify an allocator with this method, you could do that as well. But yeah, it's a contiguous growable list of items in memory. Yeah, easy to understand. And you pass in the type that it stores, and it's comp time, of course. And going down to here, you can specify alignment too, huh? Okay. And what does it do with the type? Let's see. The type ultimately, what did it ultimately do with the type? Oh, it's T. T is not, okay. So type actually is the type. That's going to be kind of hard to follow. Okay, but anyway, I guess I've kind of flipped over the details of how Zig handles compile time type generation. But well, yeah, this is so we could just say like vulnerable defending entity boxes would be kind of this structure, right? We could do like a print f and see what type this is, or something like that. But yeah, this will be of whatever type this is. I don't ultimately know what array list type ends up being. What is it actually? Can we find struct? Okay. Anyway, I don't want to spend too much time on that unless we start running into issues. But yeah, basically we're gonna have like a list that looks like this instead of this. And we're gonna have to initialize it to some capacity. Sorry. And we need an allocator. We're not gonna use the testing allocator, of course. Our game state did have an allocator. Is that where we stored it? Yeah, we did store it there. Cool. Oops. How do I go back? Hold on. Go back is alt left. Oh, cool. That's great. Alt left key. Gotta remember that. Okay, and then yeah, it would be something similar to, let's just say we're allocating slots for 10 for now. I know we have magic numbers here. Well, okay. So it's, what was it again? It's interesting. This is just, really? Did this actually work when we did this before? Give me a second here. Okay, let's go back to our hitbox code. Getting the character data. We have some tests, right? We made an allocator. Okay, so we actually have to call init like this, I think. Okay, that's the right way to do it. And we pass an allocator. Well, this is actually what I'm talking about as far as like tests go. I can look at the tests for some code to see how you're supposed to use it. This is what like the Zig implementers expect, or expect how the array list needs to be used, right? So let's go to the top of our tests. They init with an allocator. Well, sorry, this is the allocator initialization. It's not the actual array list. Array list. Array list. Okay. I don't know. Hold on. Let's get back to init. Okay, tests. So the basic stuff. They've been testing allocator. They init with the allocator. Then they go through. They append here. We're not going to be appending in that way. We're going to be like just setting an initial capacity. So I do wonder. Sorry just for being so sidetracked here all the time. I do wonder, going back to our Zig notes, I wrote down this like init capacity call here. Is that something? Okay. Initializes capacity to hold at least n elements. The resulting capacity is likely to be equal to num. Deinitialize with dinit or use toUnsliced. Okay. Do we have a test for this? How to use this? Oops. I want to look at tests. Okay. Again, this is why tests are important. I'm going to keep reiterating that. So they init with the capacity of 200. Now, I think this is where I copied the code. So you can actually check the capacity directly, the length of this. Again, they init, but it doesn't look like they. It's kind of interesting. It doesn't look like they do any tests where they add elements after they init with. What I want to see is them init with a capacity, add some elements, reset everything back to zero capacity. Zero elements. Make sure that the length still reports 0, but keep the capacity the way it is, because that's kind of what we want to use it for, right? Okay. Well, let's just give it a shot. Go in here and do all this stuff. Hey, we're learning right now about Zig, how Zig works, how their standard library is written. It's new for a lot of us. Okay. So we can't pass in 10 like this when you actually do init capacity, right? Oops. Needs to be something like init capacity. Oh, we have to pass in the allocator not to here, but to the init capacity function. Oops. With 10 elements. We'll do the same thing here, and we're just passing in the allocator that we're storing for. Right now, this is the allocator we're actually intending to use just for persistent game data, but it's because it's the allocator we have available to us. I'm using it for now. We probably would want some kind of separate allocator for our working data to use in the future. I also want to have an allocator that might be customized in the future for our rollback stuff, so that we can just do clean memory copies. We can just like copy the allocator and hopefully use that kind of to store game state. It would be just like a flat buffer of bytes. Was the ArrayList method implementation very small? Oh. Yeah, this idea, we're going to have some kind of persistent data that looks like this. No, at some point we need to actually do this call. We don't want to do this call every frame, right? We're going to keep allocating a memory. So this is obviously not where you want to be. So we're going to want some like collision system initialization stuff going on. So like, so we need some working memory for our collision system. So I think we're going to have to add a struct to handle this stuff. So I think now is the time we're going to start changing a little bit how we structure our systems. So instead of doing collision system as a function, right, we're going to call this collision system a new struct. And it's going to have a function not called collision system, but execute. And I want to use this pattern for other systems. The reason I want to do this is so that I can have working memory we can use in the system. The idea is systems don't technically have state, but again, we still need working memory. Oh, you saw stuff on GH and so? Oh, cool. Awesome. I didn't expect to ever get anybody from GitHub. Mostly people watch this are in game development through an existing channel that I know or through fighting game scene. Yeah. So basically, I want some bit of working memory here. I need to know the type of what we're working with. So let me jump over to what was it, our character data. I just need to review what we use for hitboxes. So this can be a type, array list, and with pass and perimeter of this. That's interesting how Zig works in that way. I really do like how the code generation stuff or the compile time stuff is the same code as your runtime stuff, not like C++. But yeah, a little bit of digression. Just wanted to throw a little bit of shade on C++. So what we're going to have here, we're going to have our attacker box. What are we going to call it? Down here, we called it attacker entity boxes. So let's just call it attacker entity boxes for now. And that's going to be of type generate, not hitbox, but hitbox group. Hitbox group stores a list of hitboxes over a certain frame. That's awesome. But please don't. This is a warning. This is kind of a project where you're learning how to use Zig along with building a fighting game. So I'm not necessarily using the best practices for Zig. I know things, there's a lot of like syntax and formatting rules people follow in the Zig community that I don't follow just because of my habits coming from working in on games. So anyway, yeah, so we want the attack boxes, we want our defend entity boxes, or this is called attacker and defender entity boxes. You know what? Let's remove entity for now. Oh, it might get confusing. Okay. And okay, so we have that, and we're gonna have to initialize it at some point. So let's just make an init function. And we're gonna have to init it. What do we init it? Let's take this data, initialize it here. We don't need a. Oh, actually, we need a self. Sorry, we need a self. It's a pointer to collision system, and then self dot. This should be correct. Yeah, I think we're all learning Zig together. Being surprised by things at the same time. This needs to be void. Is that correct? Is going to give me error. And we should consider deferring dinit to a certain point. This is actually a pattern I haven't thought too much about deinitializing memory that's used in structs like this. What is the common? I wonder what the common pattern for that is. You know, in C++, any memory you'd allocate, the general pattern is you deallocate it in the destructor. There's also a thing called, what is it called? Like a resource allocation is initialization. I forget exactly what that is, but is it RAII? I guess the idea is that you don't even like look necessarily at manually deallocating memory. You have data structures that just do it for you. Yeah. Such as, standard lists, things like that. I think standard lists will do it. Um, but it'll do it when your destructor is called automatically, when it goes out when its own memory is deallocated. Um, Zig, as far as I'm aware, doesn't have anything like that. Yeah, smart pointers as well. So I'm thinking about what is the pattern for Zig to do this. Now, the pattern is possible. That's cool. I mean, if you have any suggestions, I'm down to look into it and use it. Um, really strictly speaking, for this example, it's not necessarily required for now because we're running the game directly and clearing out all the memory when the program closes. But in the future, say this potentially has multiple game modes, or there releases a menu to get into the game mode and you want to return back to the main menu, you want to actually release that memory, right? So it behooves us to think about how we're actually going to deallocate this memory uh, when the game mode is over. So what did I do incorrect here that's giving me an error? Expect the test comp time var declare container field found, comma. Again, trying to get used to good habits here. Okay, let's go through here. We don't need this anymore. I wonder what compile time errors we're going to get if I try to run this. Oh yeah, if you have a reference to that, if not, I can search for it myself. But thanks for pointing that out. That's going to be very helpful. Yeah, because we really need to consider for this project how memory is going to be deallocated from our game mode. Okay. Same error came up. So we have a standard array list and a capacity. Did we include oh, we didn't include the standard? Dough. Okay. Wait, what is that? Is that why? Expect the test comp time or var declaration or container field found, comma. Can you not use do you not use comma once you start declaring functions? Am I going crazy here? Okay, maybe you don't need comma. I didn't realize that. Okay. Okay, so clearly our parentheses are not lining up here. So we created our new function. We have our init function. Can we collapse these? Start collapsing these so I can see what's going on. Actually, I want to get rid of the while loop here as well because we're not using this anymore. Okay. What do we miss? I think trying to just look for the curly bracket, curly brace, whatever you want to call them. I always get it wrong. Set it up here. What am I missing? These kind of issues are always hard to track down for some reason. uh, is this not the right syntax for this stuff? Let me comment out the internals of this function. See, try to it's probably not going to compile still. Okay. Comment out the internals of the function. Oh, you need a semicolon at the end of a structure definition. That is what is happening. You're correct, Surfcat. Thank you. Okay, cool. We're starting to get to other errors now that I guess it has context. It needs to be, okay, cool. So we need self here. It needs to be a collision system. And it needs to be self dot blibby boop liggity glue self dot whatever that is. Whoops. And just start fixing compiler errors one after another. Oh, yeah, I have different names for these, right? So, what's this? It's called naming is the hardest hardest problem in software development. I do like the code completion is working so well on this. It's just so much less a hassle. Okay, what's the problem here? Oh, it's already a capture. I don't need this. Great. I do like how clean Zig code ends up looking. You know, it's not a requirement for a language, but my God, it does help so much with clarity. Okay, so we're not using the capture yet. Okay, we'll add it when we need it. Just for that was just for conceptual idealization. Idealization, is that the right word? Defender index is used. Oh, we do need it. So, wait. So, why was? Oh, sorry. Attacker index. So we're not using the TACBlock index, right? Okay, that's what it was. Oh no, I gotta get okay, sorry. Actually compiled. Okay, cool. Compiles and runs. That's a step. That's a very important step. Okay. I don't know where the window went though, but is it still loading? Can we end the program? Yeah, we can. Okay. So now we have the basic structure here. We need to write a test to first to allocate memory. We need to start inserting items into. So what do we want to test? We want to test inserting items into those box lists, right? The attacker entity boxes, defender entity boxes. And then we want to test to see if it gets cleared out when we're done with it. Not that it's actually going to remove capacity. Sorry, it's not going to like reduce the capacity, but we need to return the size of the number of items back to 0 when we're done running the system, so that that data doesn't affect the next frame potentially, right? Or we could do it at the beginning of each loop. It's fine as well. So, you know, if I want to go down here, so what do we want to test? Let's do test. So the first thing is we want to test the collision system. I'm just going to copy paste the test from our other code. Where do we put that? I don't know why a window didn't pop up for the game. Is it another screen? Don't know what's going on that right now. Oh, errors as values were a pain for me at a point. Yeah, I mean, I I'm just open-minded at this point, just trying to see what we can learn. Okay, we're about an hour into this now. It's cool. I'm gonna go for like another 30 minutes or so, perhaps. Just checking my responsibilities here for a second. But today I don't know. I feel like I'm gonna roll on this, so I'm gonna keep going. I think we're getting a good, getting some momentum on the direction we're going with this. So yeah, let's look at what I had put in before with the hitboxes. Under the character data, we wrote some tests here. Standard testing expects it. Okay, so going back to our, I'm gonna close some of these files. They're getting in my way. Let's say initializing. So we're gonna need a collision system. Collision system is gonna be equal to collision system. So I know the pattern. So what is the I want to copy the zig pattern for using like an init function, right? So what do they do there? Let's jump in here. So they call init. Yeah, I know that, but what does the init functions end up doing? I think I looked at this before and I got a little confused, or I was tired. I don't know. So init capacity will call self.init and return self. So you do something like this. But what about the init function itself? Oh. Wait, what? Oh, there we go. So you'll do like a pattern like this, I guess. Deinitialize with dinit or use toOwnSlice. Deinitialize. Okay. It's just saying you need to deinit by calling, deinitialize by calling dinit or to use toOwnSlice. Okay, so you're taking control of it. Got it. Okay. So you return, oh, this is the pattern. So you could do something like return collision system. Oh, you do return. Oh, self. Oh. I think this works though. You can do like, and then you could do not use a semicolon, use a comma. So does that work? Oh, we need a. Oh, it's just missed it. I know it's very long here, but then can we do like? Wait, to test need to, yeah. So we can do collision system.init. Oh, we need. Okay, so right now we're passing the game state for init. I don't want to pass in game state. I want to pass in allocator. So allocator. What do we do for the other systems? Oh, we don't even do that. Hold on a second. What were we doing with our allocator? It's in the game simulation. Okay, we'll use standard memory allocator for that. Okay. So back here, we want to pass in standard memory allocator. We won't do this. We'll do this. So make it a little bit more flexible. So it doesn't. This function doesn't depend on the game state itself. That means we can set up the system independently of the game state if we need to. What is the self.if thing? Is that a special? What? What is that? Is that some kind of special statement in Zig? Returns the innermost struct, enum, or union that this function is inside. Yeah. I didn't know about this. Sorry. I've got a little bit of kuchiyusei, which is it's kind of the word of like what you say in Japanese. It's kind of habits, a way of just making sounds and stuff when you're speaking from living here. So I'm sorry if it sounds a little strange. Like he, you know, it's that kind of thing. Let's see. Test this. You list the items. List is assigned to this list type. I don't know what the list is. And the list type is here. With the items assigned to this slice. And you expect the length to be 4. I guess that makes sense here. And then what about this list struct? Sorry, I need to look at this to see if it makes sense to me. So the list will return a new struct where self, the value of self is going to be equal to this function, and then you made it. Oh, this is used for like compile time. This is used for compile time type generation, right? So it's not really what we need. We don't necessarily need this, right? I guess we could just do this, right? And does that work? Oh yeah, we need test allocator. I'm just gonna use this one. I don't know if there's a reason to use it. To use the test allocator, but I'm just gonna use this for now. Okay, whoops. A lot of what I do is always gonna do this for now. Okay, does this compile? First of all, I like compiling just to see what my mistake was. Also, init doesn't need self, obviously. Yeah. We just need the allocator. Okay. That's definitely used. I thought that was what you wanted. You know, it works as well. I guess if that's fine. I just want to go for the right you know, I want to go for the right patterns. You know, the right patterns for Zig, or just, you know, just so people who are using Zig will be familiar with what's going on, right? As much as possible. I don't want to bend over backwards for it, but yeah. Okay, cool. That works. Let's now finish our test. So what have we done here? We've allocated our collision system. So let's do a test. Standard.testing.expects. Let's expect the collision system dot. What is it? Can we not? Well, it's not completing for me. But we want the attacker entity boxes dot. Oh, that's not gonna work. Get capacity? Is that what it is? What is it? Let's go to this code real quick. Init capacity. Let me look at the test for that. We want the expect the list. Yeah, we need something like this, right? So this is what we expect to happen. We need a try here. I just want to format this. Format, not whole document, just format selection. Oh, this is not, it's not gonna like this. So, we need this. Oops, that's not right. Oh, that's not what I wanted at all. That's not what I wanted. I want items here. And then I want items to capacity to be equal to 10. This is what I expect, right? Because that we assign 10 to on the init function. This is equal to, that's interesting. Wait, so this is not, it's not the type collision system, but it would be the type pointer to collision system? So let's just make sure this makes sense, right? Okay. Okay, terminal. What's this? What? Ah, Zig test source. Error, use that unclear identifier testing. Oh, it needs to be standard testing. Okay. Expected type collision system found void. Oh, it is void, right? That is correct. Compiler tells us all. So, just looking back to the example, right? Sorry. It returns type self, and self is, I guess, oh, that's what they do. They still make this. That's an interesting pattern. Okay. I don't know if that's a pattern we have to use or whatnot, but yeah. So type collision system. Hold on. Okay. No member name capacity in hitbox group. Oh, that's a problem. Yeah. 6. What? No member name capacity in. What? In character data.hitbox group. But it's not hitbox group, right? Hold on. It's not the name of it? But isn't this... Give me a second here. I'm returning from the stack there. Okay. So, you mean on the init? This is from the stack? Okay. So yeah, it might just be habit from C++, but you would kind of expect the compiler to be able to handle something like this. It's a pretty common pattern, C++. Oh, okay. I was just assuming this would work. I don't want to confuse people, so I could do this, right? This is just maybe more clear. A little less flexibility, but more clear. But what's happening? Okay. So hold on. Dot capacity. Let's go look at our test down here. I think. Do init capacity. Oh, it's the dot. Okay, it's not the items. 'Cause that's technically just a slice. Gotcha. Okay. I'll test the opposite. I just want to make sure the capacity is what I expect. Well, it builds for sure. You do, you mean? No, I mean like we're all just trying to figure out how to get along with life here. No worries. I don't know the trade-offs yet between using something like that this statement and they call them statements. I want to make sure I'm using the right language there, by the way. The directive, a directive built-in function. So they're called built-in functions. Okay. The built-in function. Okay, 52. What are we doing at 52? Can't do this. What's going on? Error. No member name defending. Oh, it should be defender. It should be attacker and defender. Okay. Oh, let's do the opposite. We want the right order, right? For our working memory. Okay. So our attacker, defender, and error. Standard array list expects. Can I store error? Okay, got it. Oh. Do we have to do something like this? Like try what do we do it? No, we don't need to do try. Okay, I don't think we need to do try. What's the problem? Oh, I do need try. Or do okay. Let's get my brain in the right context to understand this. Clear this out real quick so I have clean. Wish I could. Can I force clean the whole terminal? I don't think I can. Anyway. Hover init, it should choose some type. I know that part, but I mean this one. Yes, okay. Oh, cool. That is actually useful. But that's not what I was looking for. I was looking for this, right? I was looking for exclamation point self. Is that because of errors? No, I do want to know. That's actually very helpful. Thank you. Yeah, I just, sorry, I'm just being thrown for a little bit of a loop here on how I want to handle this. Like you can't do like try return, right? That doesn't work, or does it work, or? Yeah, that doesn't work. Do I need to do something like this? Is this the pattern is using collision? Because like, hold on. Because you have the function init, right? They don't return, they return self here. Oh, when they do init capacity, they do this. They return allocator error self. Oh. Okay. they do something like this. So this is starting to get a little more tricky for me. It's good. Zig forces you to deal with this stuff, which is one reason I really do like it. I think it's great, especially for game developers, because you have to think about this stuff. You really should. In it, at the end of the day, you're eventually going to have to consider memory allocation, dealing with errors, that kind of stuff. Okay. So it would be standard allocator error. Is that right? It's a standard allocator. Where does the allocator error come from, actually? Is that... Oh, they did mem allocator, so it's standard mem allocator error. Is that correct? Yeah. Okay. And then if I do init down here, I'll have to do try, right? Or... how do we deal with it? Yeah, they don't use allocator there. I get it. But it's a standard error that might get thrown, right, from the allocator. Hold on. It's because the allocator self init. Well, let's return self, and they do a try, and the try might return allocator error, right? So we're also doing init capacity. The init capacity might return this, right? How do we want to handle this? Where do we want to handle the errors? No, I'm just confused. Okay, back to the drawing board. Let's reset my whole contextual understanding of what's happening. Let's just follow step by step. So my assumption of doing just like returning a collision system on initialization is a little naive, right? Because I am trying to initialize memory here, but I'm not doing any. I'm not being careful with this. So, hold on. So they do a try here, right? So I would have to potentially go like var attacker equals try this, right? And then var defender equals try that. Well, I'll have to do it same thing, but and now I don't know if this is good practice. They're kind of just ignoring the error, right? But I guess in theory this should work. No. Expected type collision system found, blah, 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 blah. Okay. Oh, because it still can return an error because of the try, right? Then... is this even necessary? I'm sorry, I'm just... like... it behooves me to read more on error handling to understand what's happening here. So, yeah, that's what I'm thinking is doesn't have the return type that includes the error. But what am I thinking is like effectively, well, not effectively, but for this example, at least for now, I don't want to bubble up the error all the way through the top level stuff because honestly, like if you can't allocate a few bytes for these hitboxes or whatever, you're don't run the game. You know, it's fine to just to crash at this point. Um, yeah, I have to admit I don't know as much about the error handling as I should at this point, so I really should learn about it. Or else unreachable. That's interesting. What's or else? Yeah, I expect it to be different for sure. So let's say if you wanted to return an error if you got one, otherwise continue with the functional logic. Okay, that's what this is for, the exclamation point. So they catch an error and return the error if there's an error from here. There's a shortcut. Oh, so that's what this does. It's a shortcut for catching the error. So could I do this? Actually, I want to undo this stuff. Whoops. So do I even need this? Hold on. Do I even need this if I want to do this? Still not what it expects. F51. Is it try here? Does that work? No. So is what I was doing before better? I'm just trying to work around. At this point, I'm doing things without fully understanding what I'm doing. Okay. Found error union, So that did not work. Oh, is that why? Oh, I see. I need to. 105 is the issue. So I need to do. Try here as well. Does that not work? Is that an error? How does that work? How does that work? Still trying to learn here. Just checking the net capacity code, test code, to see what they do. They do. Oh, you do try. Okay, syntax stuff still a little confusing for me. So, is this where we're at? Is this where we're going? Cool. Test initialize collision system. Hold on. I think my brain had a little bit of hiccup there. Initialize collision. Okay, that worked. So, if we just to see if that fails, let's change it. Yeah, it failed. Cool. And let's change this to 5. Also fails. Cool. Go back to there. So now that we have our basic setup working as okay, I just realized it's about an hour and 30 minutes here. I think we got to a really great stopping point. Learned a little bit about error handling here in Zig. Learned about um, setting up Scratch memory to work on with our system. We're not entirely there yet. We wrote down some stuff in our tech design from today. What was it? About translating data and character structures to all this stuff. No. So yeah, we're still working on creating that Scratch memory to stage those translated hitboxes, those offset hitboxes. We can actually do hit collision or overlap detection, so we can generate those events. We're not there yet, but again, we have set up our Scratch memory. We've tested that we can set it up, or at least allocate memory and handle the errors when they do occur, or at least bubble them up. So next time, what do I want to do? So we actually need to initialize those. What we need to do is we need to loop through all the active hitboxes, add them to that Scratch memory, being translated with, translating them by the current position of the characters, the entities. That's what we'll do next time, and then take that, hopefully be able to process it through the overlap stuff, the code that actually does that, which is let me go back here. That shouldn't, since we got this set up, this is kind of the more difficult, complex stuff. We should be able to go through and do all of this in the system and actually do the overlap event and generate them, so we can start testing that as well. Yeah. Sorry we didn't get as far as I would have hoped, but there's always a little bit of roadblocks with using a new language. But once we accumulated enough knowledge and experience with Zig, a lot of those issues will kind of fall by the wayside. It's not that complex of a language. I think you can completely understand it at a point, unlike C++, which I don't feel like I have any hope to ever fully understand, right? Okay, anyway, yeah, here at 132-ish point, I should check out the Gorillas repo. Cool, yeah, I'll give that a shot. Thank you, Surfcat. Anyone else who wants to see that. Okay, I posted the GitHub link in our chat earlier, but I failed to post a link to our Discord server where our community hangs out. So I'll do that there for anybody interested. You come in, talk about game dev, fighting game development, game, or just fighting games in general, whatever Zig concerns, or general chit chat. Yeah, so I'll post that here right now. Everyone's free to jump in here. Okay. Yeah, Deader Than Disco, thank you for coming by, and that goes for everybody else who took the time out of their day to hang out and chat, and hopefully it was interesting enough to keep you around and coming back. If not, that's cool too. But yeah, I hope to see you all again. If there's any questions, go ahead and ask them. And if not, I hope you all have good evening, good night, wherever you may be. It's still morning here out in Japan land, so I'll get the rest of my day going as usual. And hopefully I could submit some of these changes very soon. And I'll get the stream archive up for if you're unable to see the beginning of the stream. But cool, yeah. I like to do this more often, do these little longer streams. I did a 2-hour stream on Tuesday, hour and a half today. I like to get a good stopping point where we've learned something and we've applied what we learned to get things working. Yeah, cool. Well, yeah, if there's no questions, I hope to see you all soon. See you at the next stream. Come in with any questions you may have or topics related to the game industry. Like today, we talked a little bit about it, but always feel free to ask those questions. I can't answer a lot of very specific questions about internal company stuff, but in general things and experience I can do. So, yeah. Well, again, thanks again. Hope to see you all soon, and enjoy the rest of your day. Goodbye. Oh, I got a question here. Would you have a source with a good primer for setting up the basic things? For the Zig project, you'll have to go check out the YouTube archive. Let me post that. Hold on real quick. Yeah, we covered up setting up the Zig project at the very beginning, because we literally did this from scratch. Let me go to get the list. Yeah, okay, let me post that right in the chat here. That should be the playlist. We do cover setting up Zig, the game library using called Raylib, eventually getting debug stuff set up as well, getting things compiling in Visual Studio Code. That's about it. But yeah, I really hope that's helpful for you. And if you have any issues, feel free to ask in the Discord chat. Hopefully me or somebody else can walk you through getting it all working. But yeah, I'm going to get on with the rest of my day and see you all soon. As always, thanks for coming by. Peace.